Okay, welcome back. So we're going to continue our series of solving linear inequalities. So in this case, your first step is to recognize and identify that there's a constant term on the so-called x side that needs to be changed side to change sign, change side, change sign. The x is less than 10, which is staying at the same sign, and there's the minus 2 having transformed and negated, being negated to plus 2. Simplify. Okay, now we look at this and we identify that now the variable term is isolated, but not the variable itself, x. So the opposite to the 3, which is multiplying, multiplication by 3 is divide by 3, which in a practical and fast algebra without putting in the extra step of divide by 3 at both sides, we can cancel the 3 and the divide by 3 on the left. So yes, you divide by 3 on both sides, but we can cancel that straight away. And what it looks like is that this 3 has dropped down here. So now we have x is less than 12 over 3, which is x is strictly less than 4. Okay, now the boundary value is 4. The style of the point is, and they're the correct terms by the way, the boundary value is 4. The style of the point is, there's some, sometimes you boundary values if it's a sandwich, but the boundary value is important vocabulary for you. The point style can be like this, or like this, and the direction of the solution from the boundary point is to the left. Okay. Next up. Now 4 will not divide into 38. If it did, we would divide it in. 4 multiplication by 4 on a bracket is less than 38. So the first thing you try to do is divide. You could divide by 2 and then and multiply by 2 here and divide by 2, but most of us won't spot that and we'll go with distribution of multiplication. So if you're multiplying across a bracket, you multiply by each term in the bracket. That's why we say it's distributed multiplication. The multiplication is distributed across the bracket. So the first over arc here is worth 12x. The second one is worth 8. Change side, change sign on the 8. I'm going to go straight to 30 with that. I'm going to divide down by 30 by 12. I'm going to simplify. Calculator will do that for you. There's 6 in both of them. Okay. We have a direction, x on the left. We have a boundary value, 5 over 2, and we have a point style of hollow. Here now we have x's on both the left and the right. We bring the lesser of the two x's. This one to the left. It's a term. So we're doing change side, change sign. So we get 4x minus 2x. And if the x's are going left, the numbers have to go to the right. We change side, change sign. So we're less than or equal to, don't mind that, that's just what I wrote for using because I didn't have math functionality. Okay, take away 9. So we have 2x less than or equal to 24, x less than or equal to 12, boundary at 12, point style solid, direction to the left, variable name x. Okay, that's how it's depicted. Now, this time the 5 will divide in. So what we do is we divide by 5 both sides. And we can drop the bracket. Okay. 3, style, direction, indicate the 2 change side, change signs. First boundary point tick, then the point style, then the direction, then the variable name. Okay, here we'll distribute, that'll be handy anyway, it'll clear that half fraction. You get 12x 6 times minus a half, well that's minus 6 over 2, which is minus 3. Now you're not distributing the 6 across the inequality relationship, because that was a 6 distributed onto a bracket. It's quite a common mistake, I've even made it myself in front of classes, where I keep distributing. Okay, our x side is the left, our number side is the right, so this guy change sides, change signs. Change side, change sign. Okay, divide by 12, simplify 6 into both. Or use a calculator if you need to. Okay, a tick, a style, a direction. They all happen to seem to be going left for ages here now, and a variable name. Now 3 goes into 69, so we'll divide the 3 in, and we'll drop the bracket. Simplify. It's okay to skip this. It's okay to skip this step here. Change side, change sign. Careful. Okay, a tick, a point style, a direction, a variable name. Did I ever drop Z there anywhere? I did. Okay, so this is question 4Z. And even if you didn't do them yet, what I say is just pause this video now and do it and have a go at it. So because 3 won't go into 2, and 3 won't go into everything here, and 2 won't go into everything there, we won't try to divide, we'll multiply first. Distribution and distribution. 6x minus 9. The inequality relationship stays the same. because we're multiplying across by positive, but we're not multiplying by anything actually. We're just tidying up both sides. Okay, that'll be a change sign, so will that. If you have trouble with these and the changing of the sign, you should rewriting these up for a good while. Eventually you can stop doing it once you become very, very accurate. Okay, 6x take 4x is 2x. I'm going to start doing simple calculations alongside the change sign. You seem to be getting a 19 there. X is less than or equal to 19 over 2. There's your 19 over 2. There's your point style. There's your direction. There's your name of the variable. Okay, now there's brackets. Both two sets of brackets, two pairs of brackets on the left, a pair of brackets on the left. I'm going to distribute and distribute. Okay. 6x plus 3 plus 2x minus 8 is larger than 3x minus 5. Now we're going to, that's the first time we've needed to do this, we're going to simplify the left. Always simplify left and simplify right. There's a rule if you like. If necessary, simplify both sides before you start, before change sign. Now you could do change sides to change sign, but then you could end up with a negative if you can't keep track of the scale and the size of the x's. Okay, 8x minus 5 larger than 3x. Oh, minus 5. See how that goes? That's okay. So this guy goes this way and we get 5x is larger than 0. Well, x is larger than 0 over 5, but that just means x is larger than 5. It's larger than 0. Okay, so your boundary value is 0. Your style is hollow, and your direction is this way. Ooh. Mistake, and don't tell me I've been doing that all along. This isn't facing in the right direction. Hope I haven't been doing that all along, making terrible mistakes. Oh, is my thing opening up right each time? There's a mistake back there. You see, we can all make mistakes. Okay, terrible mistake. My thing wasn't going that way. Tut. So P should have been, this should have been twisted. So you can see how easy it is to make mistakes in maths. If I can make a mistake in maths. Okay, 3 over 2. So there's a very important rule just towards the end, and I'll apply it more rigorously in future. And there's where the rules do come in and keep us on the straight and narrow, because sometimes our logic can get hijacked and we can think we know it all. Okay, which is why I suppose I need to be corrected from one day in class where I kind of said, look, you don't need rules when you have logic and thinking, mathematical thinking. But we tend, as humans, we tend to look for the automatic way of doing things. We're actually, it sounds ironic, but we actually don't like learning. We like being good at things that we do over and over again. That's the truth of it. That's what a psychologist will tell you. So that was my mistake here, to be so full of myself that I didn't think about that inequality and see is it facing in the right direction. So what I should have done was gone in with my boundary. No. Yeah, should have gone in with my boundary. X is larger. No, I still haven't got that right. Look, the x has to come over here. It has to bring this with it. And 3 over 2. Are there any others I made mistakes with? Oh my god, yeah, that one. So the direction, I'm right up as far as here, but my direction should have been that way. Same thing here. Same thing here. And I should have smelt a rat when they were all facing in one direction. Okay, I'll wrap this video up and post it.